Okay, in this video here we're going to look at logarithms, particularly the log laws, how logs are structured, and essentially what they are inverse exponentials. So there's this idea of an inverse, so logarithms are inverses of each other, just like how plus and a minus goes with a times and a divide. Exponential equations, if you have a look, it is structured as a to the power of x, which will give you the value of y. Now, if we restructure this is equivalent to saying log with a base of a, so the base is the same, of y, which is that value that we obtained there, and x is the power. So when you're calculating a log, essentially what you're trying to do is you're finding the power. Now, when we're reading this, we can say, we read it as the logarithm base of y. So log base of a of y. Okay, log base a of y. In other words, if you actually want to calculate what that is, you say, well, what power of a will give you the value of y? So let's dive into a couple of examples here. You can see that 2 to the power of 4 can be rewritten as log base 2 of 16, which will equal to 4, and you can see 4 is the power there. Okay, 10 to the power of 4 can be written as log base 10 of 10,000. As you can see that there's 4 zeros there, and the power is 4. So 10 to the power of 4 is 10,000. And it's just a way of rewriting this. So we'll have a look at the example number 1 here. And I'll zoom in a bit. Essentially what we're saying here is we are finding log base 2 of 32. That's how we read this little phrase here. Okay, that's how we read our little question here. Now, the way we want to calculate this, or the way we want to find out, is we can rewrite this as 2 to the power of what, or 2 to the power of something equals to 32. Now, if we take this as a little calculation off to the side, we can work on this 32 here and re-express it as 2 to the power of 5, which means that whatever is in that box there is 5. So the power is 5. Which means that log base 2 of 32 is ultimately equal to 5. And you can see there we're calculating without a calculator. Moving on to part B here, log base 3 of 81. Essentially what we're asking is a base of 3 to the power of something equals to 81. We can work on this exponential format here and re-express 81 as 3 to the power of 4. So what sits in that box there? That is 3 to the power of 4. So log base 3 of 81 is equal to 4. Moving on. Here we have log base 5 of 1 over 125. What this will look like is, if we rewrite this in an exponential format, it's 5 to the power of what equals to 1 over 125. We're going to manipulate the right hand side here a bit, so 5 to the power of something is equal to 125 to the power of negative 1. Because we are taking the denominator into the numerator, therefore we are introducing negative indices. This 5 to the power, this 125 here can be re-expressed as 5 to the power of 3. And because we have those brackets, it's encapsulated in a bracket because this 125 here is technically in a bracket. Now that we have two indices with brackets in between them, the log law, or the index law, sorry, is that we multiply. So we've re-expressed it as the same base now, which means we can do a direct comparison of the powers. This means that 5 to the power of negative 3 is equal to 5 to the power of negative 3, which is 1 over 125. So to evaluate this value here, our answer will be negative 3. So sometimes we do want to manipulate what we have in our bracket here, and you can definitely see that with the next question as well. If we have a look at log base 10 of 0.000001, we can rewrite this outside of the side here. That's going to be rewritten as 10 to the power of something equals to 0. How many zeros do we have here? 1, 2, 3, 4, 5, 5, and then we have 4, 5, and then we have the 1 there. Now, I want to re-express this as a scientific notation. However, I do want the base to be a 10. Okay, so look, this 0.000001 is going to be written as 10 here, and I do want that decimal place to be at the very end. What we're going to ask ourselves now is how many decimal places do we move that to the left? So we've got 1, 2, 3, 4, 5, 6, 7 spots, which means that this is 10 to the power of negative 7. So if you type in 10 to the power of negative 7 into your calculator, you should get that value there. We're going to compare it directly here. And since it's the same base, we can make a direct comparison with the powers. It's 10 to the power of negative 7. So this value here is equal to negative 7. So 10 to the power of negative 7 gives us 0.000001.